Today I will be discussing about the question and topic for section B to question number 8, which is this one. A ball of mass M 1.8 kg is released from rest at height h 65 cm above vertical spring of force constant K. The ball strikes the top of the spring and compress it at a distance of d, which is 9 cm, not neglecting any energy losses during collision. The question A asks me, find the velocity just before it touches the spring. So this is the situation given in the tutorial in the question number 8. So how to find the velocity just before it touches the spring? Alright, that means basically just before it touches the spring. So it will fall down just before. So here at this moment here at h distance, it's going to be where it's going to be just before it touches the spring. So we know that it is released from rest, so the u should be 0, second at 1. And then our h is this one. Remember, it's in centimeters, so you need to change it. So it will become 65 meter, 0.65 meter. And then there's d, which is not now. It's not going to be used now, so it's going to be 0.09. So we're just going to list everything that's possible here. And k is a constant of the spring. So we know that we can see the form of linear equations here since we solved v. So we can use the equation like v squared equals to u squared plus 2as. Now, just as I said before, at this point of when the ball is traveled h, that is going to be the point where the ball just touches the spring. So we know that s is going to be 0.65. 0.65, but negative. Remember, s has a direction. So v squared equals to 0 squared plus 2 and a. A is an acceleration. We know that a is going down, so it's going to be negative. Remember, acceleration must have direction. So it's going to be negative 9.81 with the displacement of 65. So if you do everything, you calculate everything, you will get v as 3.57 meter per second. This is how you get the velocity for question 8a. Now, let's moving on to the question B. How do you find the force constant of the spring, which is this one, which is the constant of the spring? Now, I will be erasing everything this up. Now we have the V, which is already fantastic. V now is going to be 3.57 meter s negative 1. Alright. Now, B. We all know that the sum of energy in initial is equal to the sum of energy final. This basically means whatever losses of energy or anything, it's going to be the same if you add up all of them together once more. So the possible energy here is going to be the gravitational potential energy since it was dropped down, and then there is spring. So there is going to be a potential energy of spring. So there is going to be mgh. This is initial part only, 1 over 2 kx squared equals to, once more is basically the same, mgh plus 1 over 2 kx squared. Now, the first energy of spring, we know that x has no extended or like compression or extension. The spring here doesn't extend or it doesn't even compress. So we know that x here is going to be 0, right? So if this is 0, so we know it's going to be mgh only. And here it already touches the ground, which means there is no longer H. I mean, it's no longer going to be H because it's already touched a certain surface, which is the spring surface. So we know the H here going to be 0. So we know this can cancel. So now we have that and this. If we write it together, we will get equal to mgh. Okay. The mass is 1.8 kilogram. 1.8 kilogram. The gravity, the gravitational acceleration, which is g, is going to be positive. There is no direction for g. So it's just going to be normal like this. And the h is basically the distance traveled by the ball when it goes down. When it goes down, so it's going to be m and d, the distance just before it bounces back up. So it's going to be h plus d. So 0.65 plus 0.09. 0.65, 0.09. Yes. Now the other side, however, we're going to get. How am I supposed to write this? Going to be 1 over 2. K is the one we need to find, and the x is going to be d, which is 0.09 squared. Now, if you do this, I'm sorry, it's supposed to be down here a little bit. We just don't enough spaces here. You will get K as 3226.4 Newton per meter. And this is how you do the question 8b. This is the spring constant. Thank you.